because if you're learning plugins, pretty much anything that you want to do, there's something like it done in one of these plugins. So these plugins are not only great for building apps, but they're great as a resource for you if you want to know how to actually do something. So battery status, device motion, these are good for if you want to do a sensor API, so you can have a look at those. Camera shows you how to create a complete view for the camera, put it on screen, take a picture, and return that data back to JavaScript. In-app browser is a great example of putting another view on top of the Cordova view. The status bar actually lets you mix a piece of native view with the web view that's already in the app. So the first thing that you need to know about plugin authoring is that the plugin.xml is your starting point. That defines the ID, which is hopefully unique, so you can publish it to NPM. It also includes some meta information like version number, your name, similar to package.json, and actually once you publish to NPM, it's actually going to be copied over to package.json. So inside your plugin XML, you define a list of resources that you want packaged with your plugin. So this could be images, this could be source code files, this could be DLLs, it could be separate projects, or it could be JavaScript modules. It also contains configuration items. So if you need to set some permissions in a manifest on Windows, you can do that through the plugin XML. And also, one of the key areas is the JS module. So this is how you define your JavaScript API. So I'm going to give you a quick walkthrough of an existing plugin. So like I said, this is why I consider these all great resources, because you can go and look and see exactly what they do. So here's the plugin XML for the device plugin. It's got some namespace items. It defines an ID and a version. There's a plugin name, a description, a license, etc. And then we get down to a JS module. So this is the file that is going to be defining our API that we want our users to call. And then if we look in the platforms folder, there's a bunch of platforms, and we scroll down and we see iOS here. So this is the portion that is used when you Cordova platform add iOS. This is the portion of the plugin that the iOS is going to use. So it's got some things like it names a feature, which is device. It's got a native class that it intends to call, and that is CDV device. So when you make an exec call from JavaScript in your module to device, it's actually going to go and find this class for you. This class is going to be defined in your source file here and your header file here. And if we jump over to look at those, I'll just show you quickly the mapping here. So we've defined our module in www/device.js. And this is not the actual JavaScript that's going to be run. This is all going to be wrapped in a module, and it's going to be loaded for you automatically by the framework. So you can see that we find the exec call here. So exec is actually Cordova exec. There should be a require somewhere here. Require Cordova exec. So we're calling exec and we're calling it device. So this is information that's passed to iOS. And get device info is the native method that we're going to call. So if you recall in the plugin XML, we defined that when we receive the device message, we're going to map it to that class. So if we navigate back to the iOS source, and we'll see those two files that are included. And get device info is the method that we're actually going to call. So I'll get into the nitty-gritty of doing things inside the plugin in a bit, but that's sort of the definition of how things are mapped from plugin XML to what's actually run on the device. So is anyone familiar with Plugman? A few of you? Okay. Plugman was originally what we were using to install plugins, and it was a tool that we used on its own. It's now actually used by the Cordova CLI to manage plugins. So it's Plugin Manager for short is Plugman. It also has its own CLI. So if you npm install Plugman, then you should be able to do some of the dirty work of creating or installing a plugin. And I'll show you, it has some nice features that are of more use than actually installing plugins. Plugman has a method to create a new plugin. So instead of you having to memorize all the namespaces that you have to add to that plugin XML, this will allow you to simply type Plugman create with a name for your plugin, an ID for your plugin, and a version and a path. So I'll just show you this really quick. You can copy and paste along with me if you want. So Plugman create, my plugin name is plugin name. The ID is Jesse-plugin-ID. You can change that if you like. And the version and the path is just the current directory. So if I ls, you'll see it's created a new folder for me. This was a bit of a surprise for me, actually. I expected it to do it in the current directory, but this is one of the things I learned when I was going through all of this. So if I change directories, and you'll see that it's created for me a plugin.xml. Everyone like reading it like that? Can you see that up there? So it's done the dirty work of basically creating a module for me and a plugin name. So it hasn't added any platforms. I still have to do that myself, but it's just given me a starting point, so I can use that to move on. So that's a helpful little feature. So an important part of plugins is that they can also depend on other plugins. So this allows you to actually go and, where can I go? Okay, I'll open this folder in Sublime here, and I'll look at the plugin XML, and I can actually add a dependency. So now I've said that I depend on the device plugin and I depend on the console plugin. Now, if I wanted to, yes, absolutely. You can be version specific and you can be version somewhat specific as well. So you can require a minimum or a maximum. So let me see if I can. Hopefully this will work. Was it my plugin? Thank you. So I've added iOS, or I am adding. And you can see it's installed Jesse plugin ID. It's also fetched from NPM, Cordova plugin device, and Cordova plugin console. So I've written a very simple plugin, but if, for example, you always use those two plugins, you just made a plugin for yourself to save yourself some time. So now we get into a bit more of the plugin functionality. So this slide doesn't really look great because the formatting is not showing up. But this is the JavaScript in your module in JS. And this example is straight from the status bar plugin. So we're saying exec status bar and call the method style default and don't pass any arguments. I'll get into a bit more with arguments in a bit. Now in the iOS platform section of the config XML, we're also going to have status bar defined here, and we've defined CDV status bar as our class entry point. And another side note here is some plugins you need to have instantiated right away when the application starts. So if you add this, then the framework will actually load that plugin for you, and it'll be available before device ready. So going on to CDV status bar, we can see that there's one method that's called. And in this case, we're just setting default. We don't care about arguments to the method because they're empty anyway. And we're not actually doing any sort of callback or anything. A little bit more complicated version of this is the CDV status bar also has a fire tapped event. So this allows when you tap on the status bar, it'll scroll the web view back to the top. And this is actually done by sort of tricking the view into thinking that there's a scroll view, that it must scroll back into view, and then it intercepts that event and it passes it to JavaScript. So we actually pass that in by creating this object. So whenever this event occurs, fire tapped event, because the user has tapped on the status bar, we'll get this method called. We'll create a payload, which is essentially a dictionary. And this just turns into a normal JavaScript object once it's passed back through. So we're going to create a plugin result. This is a type that's provided by the framework for you. So you create a result with a status. In this case, we're saying everything is okay. This is a success message. And we're creating a message to send back with this dictionary, which is right here. And that just tells the plugin result how to actually set up that data to pass it back. So there's helpers for message as bool, message as int, message as string, if you want to pass back different data types, and it'll handle them for you. And then also in this case, this isn't a case of where from JavaScript we've called native and we expect a result and then we're done. In this case, every time that the user taps on that status bar, we want a message. So we're setting keep callback to yes. This means that that callback will still exist. And you can see we're using this callback ID. This happened on init. So there was an init call from JavaScript into native. And at that point, it was given a callback ID. So we're going to reuse that callback ID for every time that a tap happens. So then we just call the command delegate and tell it to send our result back. So I can actually walk you through an Xcode project here. I've got the status bar plugin is installed. Is that showing up okay? It's a bright screen. So, let's see here. If we, let me set my breakpoint. If you look through, you'll see plugins, you'll see status bar, www folder status bar. Here's that wrapper I was talking about. So that's what the framework added around our module when it installed it. And we look over here to the native side. So this is still in the project in plugins, cdv status bar.m. And here's the fire tapped event. So this is the same code I was showing you on the slide, and it actually looks a lot better here. So we can debug this. I can actually just show you. Okay, so if I click here on the status bar, you can see that we've got this event has triggered, and I can actually step through this. So events callback ID exists, and then I create a payload. I'm going to pass it through, and presumably, and I would do something with it on the JavaScript side. In this case, I'm not doing anything, but I just wanted to show you that you can actually step through those events and see what's actually happening. And let's see if there's another, what other results we're doing in here. So this does a similar thing. This is just, if we call in to set is visible to true or false, then we're going to call back. So there's nothing new there. This is very similar to what we did above. So I'm going to come back to debugging a little bit more in a bit, but I'm going to jump over to publishing for now. So npm is now where we publish all of our plugins. So you're going to need to have a package.json if you want to publish. So Plugman has a nice method for that too. So going back to the plugin, it's a great name for a plugin, by the way. So I can simply, I believe I can do it like that. And it's looked through plugin XML, and it's pulled out plugin name from there, and it's asking me if I want to use that in package.json. So I just hit enter. It's pulled the version number. I can add a description here since I didn't put one in the XML. Is that spelled right? A Git repository if I want, author. And then it asks me if that's okay. And now we can see it's created package.json for me. And it's populated that information for me. And now if I'm ready, I can just Uh-oh. Okay, that's new to me. Well, let's see if Plugman will let me do it again. Yeah. Yeah, it's out there. It's live. You can go get it. I'm sure you want to. So, what is it? npm unpublish? Is that right, Steve? And just local. So I hope you got it in that brief moment there, because it's gone now. And I think that ID is used forever, right? So no one can ever make an npm package. Yeah. Okay. Maybe I'll publish it again. Yeah, there you are. I should be asking you. So we know most of what plugins can do, but I'm just going to present to you some other things that you might not have thought of. So a plugin can add functionality at runtime, which is what we're used to, but it can also add functionality at build time or even install time. So at runtime, we're accustomed to helpers doing things for us, exposing native functions. Could also be providing hooks for QA or maybe a file logger that you want to upload or analytics, those sorts of things. But you can also do plugins at build time. I'm not going to go deep on this, but you can actually pre-process stuff inside your app before you actually build. So you could be, transpiling ECMAScript 6 to straight up JavaScript. Or does anyone use CoffeeScript anymore? No one? Did anyone ever? So you could also be doing SAS processing. Webpack has become quite popular. So that's essentially inlining a bunch of JavaScript and images into one single HTML file. Or you could be analyzing code. So you could be linting or checking code coverage, those sorts of things. So if the tests fail, then you don't actually let it build. You say, oh, there's a JavaScript error here. So plugins at an install time, essentially, if you're packaging other plugins together as a single plugin, that's sort of an install time plugin. Or you could write a plugin that provides tests for another plugin, and I'll show you how to do that. First, I'm going to show you a little bit more complicated demo. It's actually the app that I showed, but it does a bit more than what I demonstrated already. So I wanted to do a fairly complicated plugin, and it turns out that this was quite complicated. I wanted to mix some native UI in with the web view and have it callable and modifiable from JavaScript. So I wrote, it's called the PhoneGap plugin sidebar. Originally it was going to be Hamburglar, but so iOS is supported quite well, and I'll just demonstrate the app for you very quickly. Let me change the size on this guy. Still too big. Okay, I'm gonna close it and restart it. And hopefully it'll adjust to the screen. No, it's still big. Okay. 4? How about just 6S? I don't want to go that far back. Yeah. The 2? Yeah. Tell I run this one a lot. Okay, there we go. Okay, so I'm sure you saw media related demonstrations earlier. So if we look at what I'm doing here is I'm in JavaScript in my application itself. I'm calling this friendly URL to the iTunes store and asking it for software with the term love in it. We can make that PhoneGap. We want explicit and we want 200 items. So see, it's already running. I'll show you the results with love. So this is the component that I created, and it's actually a nice scrolling table view, and the results are coming from JavaScript. And it lets me select an item, and that data is passed back as the index into JavaScript code. Excuse me. So you can see our results here are stored in an item array. So I'm doing a little bit of processing on them. And then on the show panel method, I'm calling PG sidebar, which is the JavaScript object that I've exposed. I'm calling the show method. And I'm passing it a success handler, an error handler, and then my list of items. And then if we dig into the plugin JavaScript, we can find the show panel method, or show. That's status bar. So we can see the show method, and essentially all I'm doing is I'm calling exec with the callback, the class name that I've mapped to, the show method, and I'm passing the items an array of arrays. So everything that we pass through exec is going to be an array. In this case, it's got one item, and that item is a list of strings. So on the native side, we're going to receive a command, and this command is going to have a list of items. So we're going to do some magic here to actually set a list of items for ourselves. So this is already an array of strings for us. So all we have to do is set this property that we're storing on the native side, and we're storing the callback ID because we're not going to call back immediately, so we need to keep it for later. Then we're going to do some magic with the actual UI view. So this was the complicated part. So getting the rectangular size from the web view, putting another table view right beside it, the same height, and then adding a nice drop shadow to the web view so that it looks like it's hanging in front of the table view, and then telling our view controller how to lay out those views. So we add the table view as a subview, and then we bring the web view to the front, so our drop shadow will show over it. And we have a nice magic number, always 240. That's how far over we're going to slide. And we're going to do an animate We're going to animate over 200 milliseconds. And this is what we're going to change. So the iOS SDK controls all the nice, beautiful animations for us. Really, we're just saying change from that frame to this frame, and it does it using this nice ease in out over that length of time. Then when it's done, it calls this method, and we're going to send plugin result with the callback ID. So that's just to tell the JavaScript side that we've shown it. So if we want to step through that, so we can see, and show me. Our invoked URL command, it's got a list of arguments. So to it, it's an array, and that array has strings in it. And that's what we're storing locally, and then we do the magic to actually display it. So now scrolling is all done natively. We don't have to do any extra work. The items are there. This is part of the table view controller interface. This is some of the native stuff that you'll have to dig into yourself if you're doing a plugin like this. And then we have a method for item selected. Did select row at index path is the method. Nice table view, nice short name. So we're going to create a plugin result, and because JavaScript passed us the array and we assume that that array hasn't changed, we don't actually need to pass back the string. All we need to tell JavaScript is the index of the item that was clicked, because JavaScript knows what the actual item text is and any other data that it has attached to it. So we use index path to get the actual index of the item, and we send an OK status. And then we send the plugin result. See, there's that message as double. So in this case, even though it's an int to us, it's a double in iOS in Objective-C land, and we pass it back in. On the JavaScript side, where are we? Right here. Essentially, we're just going to pass it back through to this success callback handler, which is defined in the original call. So it's this method right here, and we'll set a DOM element with the text from the items at that index, and then we'll call hide panel. And hide panel is another call into native to just throw away that view. So that's the full scope of the plugin. And this hopefully is an example that you can step through on your own and have a look at the way that the native UI and the web view are interacting. I actually had quite a few pitfalls with this. There was things I didn't know about the status bar that really affected the way things worked. Because originally I was working on this without the status bar, and things were working great, and then I installed the status bar plugin, and all of a sudden my drop shadow was showing up across the status bar. And all of a sudden the table view wasn't scrolling, because as I mentioned before, the status bar has the trick where it adds a scroll view, and it uses that scroll view to trigger the tap on the status bar. And because that scroll view was placed in front of my table view wasn't interactive. So I had to configure how I actually laid out the items to make sure that my table view showed up in front of that scroll view. So that's one of the pitfalls that you have to be aware of. You don't necessarily know what other native plugins are doing. So you should warn your users if you're doing anything tricky, and you should try to inspect as much as you can in the view for cases that you can actually do something about. Well, what I was doing is I was pushing to the back, which is always whatever was pushed to the back the latest is at the back. So I didn't realize that I was pushing to the back and that was behind that scroll view. So I changed my method to, am I in the right one here? I changed it to, where are we? I added the subview and then I brought the web view forward. So that was the approach that worked. So everything else can still be in the same stack. And as far as changing the shadow, I got rid of the vertical portion of the shadow so that it's only making a shadow side to side. And that was good enough for me. Presumably, if there was another control on the right-hand side, it would have an issue. And I would like to actually make this control be able to work on either side of the web view, or perhaps more than one at once. So that's something that will have to be explored at that time. Not yet, but very soon. What's that? You can, and you'd need to talk to Shaz about that. It's not trivial right now, but he plans to make it so it's a lot easier. It's something about the way the Xcode project is set up in the latest release, but there are some additional arguments that you can pass that will allow you to mix. So the most important part of making a plugin is making sure that you can test it and it works like you expected it to. So again, using all the core plugins as a reference, if you look at any one of them, you'll see a tests folder. In that tests folder, you'll typically see a test and a plugin.xml. So back to plugin device. Here's a tests folder. We have tests, which are essentially written in Jasmine, so JavaScript. And you define what you expect to happen. And this itself is actually a plugin. So this plugin, all it does, and there's another plugin, which is the test framework, which manages all the tests for all the plugins and will run them. So it does the dirty work for that. Going back to tests, so the way that we define what we want to test, we have the concept of auto tests, and there's also manual tests. Manual tests I don't use as much because I'm usually developing an app at the same time as I'm developing the plugin, and my app is essentially testing my plugin and all the functionality that I want to expose. So I'm, putting a button on the screen and then attaching an action to actually test some of the native functionality. So I don't define it, but define manual tests allows you to programmatically build a UI. So it has methods to actually add buttons to the screen and connect them. It's got this create action button, but I actually honestly haven't spent a ton of time here because I'm usually doing it myself. But more interesting is the auto tests, because auto tests allow us to, make sure that window.device, the API that we intend to expose, is it defined? It'll test if platform is there, if platform length is greater than 0. So platform is the name of the platform that we're built for. So iOS or Windows or Android. So continuing on, we're checking that our entire API that we expect to be there is. Any of these that are false will actually be a failed test. So as far as running tests, thought there was another slide here. Okay, it might be ahead. All the tests for all the core plugins are using a tool called Cordova Medic. So Cordova Medic essentially installs all of the plugins, one particular platform, and it will run all of those tests together. So tests are in Jasmine 2.0, like I said. And all of the plugins individually have a test plugin, which is installed, which contains the actual tests. So Medic is great for Cordova and testing all the core plugins. But if you're just developing your own plugin, you want an easy way to actually just test that. So since a lot of what Cordova Medic does is breakable into little pieces, I did that, and I spun another tool based on it. So I called it Cordova Paramedic because the actual definition for paramedic, I think, fits very well with wanting to test, in the field, essentially. So Cordova Paramedic allows you to specify a platform that you want to test and a plugin that you want to test. It expects the same thing. It expects there to be a test folder, and in that test, it expects to find a plugin.xml that defines the tests. So here's what it does for you. It creates a temp project. It adds the platform that you specified. It installs the Cordova plugin test framework plugin. It installs the plugin that you specified, the tests for that framework, for that plugin. It sets the start page to the test framework page. And then the hard part, the important part, it's a command line tool, and we want to actually get the results back to the command line. So it creates a local server, and it listens for data to be posted back. And then it exits with success or fail based on the results of those tests. So how do you go about writing tests? Well, do what I do. Just copy one of the core plugins. We can actually, I'll step quick one that I did. Actually, let's go to a Cordova core, and I'll just run Paramedic for you. So we'll test that device plugin. So you can also npm install Cordova Paramedic. Excuse me. If you want to do this yourself, and then you can just Cordova Paramedic. iOS, and if you don't specify a plugin, it'll actually look in the directory that you're in. So you don't actually have to do that last part. So it's creating that temp project for you. It's installing tests, the framework. Hopefully the tests pass. And, oh, that was still attached in debugging. Oh, and it's running on iPhone 6. Okay, it doesn't look great, but let's see. Can I get, yeah, okay, there we are. Okay, ignore Xcode here because it's not in use. So we've actually run our tests. You can see 11 specs, 0 failures. So then on screen, we've actually output the tests that we've run. So should contain a serial number specification that is a string. So we've passed that information right back to JavaScript here to our server. And we can see the same data. So 11 specs run, 0 failures. We exited with success. So this is a quick way to smoke test. You add a new API. You want to make sure you didn't break one of the old ones. You write a new test for your new API. You simply do Cordova Paramedic run with your changes, still passing. It's pretty quick. And you can actually test more than one plugin at once. But for practical purposes, I'm usually doing it per plugin when I'm working on a plugin. So yeah, I would advise that you don't try to memorize what those tests look like, and just go and look at them in an existing repo. So this is for the sidebar. I wrote a couple tests, so it should have a show method. So I expect that to be defined, and I expect it to be a function. And same with the hide method. So I showed you a little bit of debugging native code in Xcode. Are people familiar with that? Xcode seems to be the most popular of the platforms that we support. But I could dive into that a little bit more if anyone wants to see some more. Yes. Okay, well, we'll see how we do on time, and maybe I'll come back to that. I'm going to show you a little bit of Windows too. I was going to start that. So we talked a bit about the bridge in iOS and how it works and how it translates messages. Well, when Windows 8 came out, all of a sudden JavaScript was a first-class citizen on that platform. So there's a lot of grunt work that we actually don't have to do because we can just call the SDK methods directly from JavaScript because our entire application is JavaScript. So going to, let's go back to device. If we go and look at plugin XML and we go to the Windows portion, you can see a similar JS module up here above all of the individual platforms. We still have our JS module. The reasoning here is you could actually replace this JS module with one that's just for Windows, and it could call all of the APIs directly. But in most cases, this device JS has already done some input checking and validation on, if a callback method was specified, if you're passing the right arguments. So in order to reuse that code effectively, what we did is we actually just proxy. So we mimic there actually being a Cordova exec, And really, it's just going to take the same data that we would pass to native, but it's just going to pass it to another JavaScript function that has the same methods. So in practice, we go source and Windows, device proxy JS. So the methods that the device object is exposing is simply get device info. So what we've done is we've provided the same function, but we know that we're going to be called with proper callbacks because it's managed for us, and that the arguments will be valid. In this case, I don't think we even use the arguments, but in other plugins you do. So now we're going to do some JavaScript work here to actually fulfill the data. We have JavaScript promises available to us. A lot of the Windows JavaScript SDK is based on promises. So we embrace our async and we actually do our callback. We call the win method, which was passed to us, with what we would expect if we had called native. So a platform, a version, an ID, exactly the same data. So the one bit of trick here is we're asking Cordova exec to proxy this method. So that means whenever you receive a call of Cordova exec with device as the key, just call this method, which we've defined here, or this object. So it's going to call get device info on that object instead of where we would have passed it to native in other devices. I could show you that here. Here's my son. Who's running Windows? Julia? Right on. I spent a lot of time in Windows. Now I do both. So we can also do Cordova Paramedic in Windows. And I can show you the sidebar in Windows, but it doesn't work as well, which I'll explain. Not now. Okay. So back at our familiar device plugin. I use device because it's quite simple, but it still does everything that we need to see. So I can and fingers crossed. So similarly, we go through the same steps. We create a temp project, install the plugins, add the platform, run it. And I'm just going to Victoria's Secret, except from my history. Yeah, Windows is not liking this resolution on the VM. That's huge. Yeah, my VM is choking. Okay, let's go back to our tests here. You can see we ran 11 specs, 0 failures, and is it still running? Alt tab. Too many windows. Yeah, I think I'm just going to say that everything works pretty much the same. But one of the beauties of using Visual Studio with Cordova is the fact that you can actually debug JavaScript throughout. So it could be your application code, or it could be plugin code, because there is essentially no native. So you're working through JavaScript strictly, and you can step through completely. Okay. You know what? One sec. Yeah, that one. There's that window. Now I have a failing test. Anyway, I'll have to look at that another time. So the Windows Bridge has a proxy, so it's not like Android or iOS in that there's no translation layer or bridge that actually converts objects for you. There's no need. So publishing your plugin, we saw that. Documentation, of course, you should document. If you look at the core plugins and how they work, typically the README is in English, if English is your main target audience. And then there's also a docs folder which will contain different translations for other languages. So were you expecting homework? Because you're getting some. So one plugin that I've been wanting to work on, which I think would be a great starter project for someone, is the globalization plugin. So what it essentially does is it'll format dates and it'll format currency based on the settings on the user's machine. But the way it does it right now is it actually calls native, it asks native to do it, and then it passes back to JavaScript. And in reality, all of this information is known as soon as the plugin is initialized. So if somebody wanted to actually do a meaningful contribution, this would be a great one. So you could get that information from the plugin when it starts, and then instead of having all these async calls, you could actually return the formatted data right away. It's actually really hard to work with the globalization plugin because you want to display a date in the view, but you actually have to wait and enter that into the view later. So this would be great. Yeah, I can jump into threading a little bit. Always create a new thread or a new block would be the advice. So if you look at any of the core plugins, we've gone through and made sure that everything is on its own block. So trying to find a good example for you.
Is that true of all plugins or just
You would have to talk to Shaz. He's the iOS guru on our team. But I think in most cases, I mean, absolutely, if you're doing any sort of lengthy processing, you're going to want to create a new thread to do it on a background thread. Because you don't want to interrupt the UI. It doesn't look like there's any blocks in here.
is that, when you say blocks, is that like a dispatch async?
Yep. Yeah, with the thing with any sort of plugin that you're going to be doing, you're going to have to actually really understand the native portion, because it is more complicated than actually making an app that uses plugins, because you have to understand both sides of the fence, right? So, but digging into the core plugins is a great place to start. I'm still not seeing. Okay, here's some blocks. So we're creating a weak reference to ourself or to this object. And then we're going to call this. So this essentially is running on a background thread. So the start recording method here, and then we dereference the weak self, and we can actually pass some data back through the command delegate. So this could have been written as this, or self in Objective-C land, but instead, because we're doing this inside of a block, we want to keep a weak reference to it. How am I doing on time?
You got 20 minutes.
20 minutes? Do you want to do a demo of
Yeah, sure.
hooks? Yep, absolutely.
Plugins are practically attached to the app itself, okay? And the case in particular, for instance, with Android versus iOS. Android preempts activities versus iOS preempts the application. So
Yep.
it's app oriented, the other is activity oriented. But there is an insight, I think you know where I'm coming.
Yeah.
The case of the camera.
Yep.
Okay? That when you could be lucky and get back your result, or otherwise.
You can't assume that though.
And then you go to La La Land and restart the whole thing. Are there any, I think that this potential will continue for any possible other peripherals to the device.
Yep.
Are there any plans on looking into that direction, or?
The camera plugin has actually had an update, which is using a new method. This is in the latest Android. So what it does is you can actually check for a plugin result before you call the method. So instead of calling camera get picture, you call camera get result. In the case that you were dumped out of memory and then restarted.
Yeah.
So, and that information is still available to the plugin.
But that's sort of like a workaround.
Yeah, but there's,
The question comes about, you know, if Cordova is gonna house or provide somewhat a way to, you know, hey, make these to be bound to the thing, because I mean, I found a workaround.
Yep.
That actually was to wrap up the camera thing, but then now you open another can of worms because now you lose the UI. You have to create your own UI because all you're doing is using the primitives of Android.
Yep.
Okay. So now you're presenting the user with something totally not familiar with.
well, the goal is that you call, the second time your app is launched, you don't necessarily know it in your application. So you call camera get picture, and the plugin itself checks if there's a stored result, and it'll pass you that.
Okay.
So the plugin is going to hide that from you. So
in other words,
to you,
so you potentially could restart. It
Yep.
will restart the application.
Yep.
Now it's up to you to track where were you at.
You
So-
do-
so
you would-
launch- so
yep.
you launch yourself down to that position.
Yep.
Okay.
I'd recommend checking out the new Android release blog post. You go to Cordova.io, go to the website, and they actually go through a description of how to use this new interface.
The problem with those is, and this is a reality, I mean, Android is not updated like iOS, everybody.
Oh, you mean for older platforms? I mean,
Exactly, I mean,
So-
you have, I mean, I had even the situation, one guy having 5.0 and the other 5.1.
Yeah,
Okay?
yeah.
Same brand, the guy of 5.0 never got the upgrade until God knows how many months. In the meantime, you have to read it.
yeah. So when we say like a new Android update, we're not necessarily talking about the version on your phone. It's more the Cordova Android update.
Oh, okay.
So we just released Cordova Android 5.1, I think it is,
excellent.
and that supports Android 6,
Mhm.
but it goes all the way back to API 15, I want to say. I don't know off the top of my head. I mean, our Android guy, I think he's just
10 is gingerbread.
Yeah,
The
we don't go
2.3.
that far.
Okay,
Yeah.
so you must be going like 14.
I think we
So
go-
that's
I think we go 14. Yeah, we go to 14.
ice cream.
Yeah, ice cream. And so the new Android will actually support all the way up to 14.
I mean, I know.
I know you
More
wanna keep-
because I got my hands
Yeah.
dirty, but
I mean,
I'd rather do it in iOS. I'm out the door, you know.
Yeah.
Yeah.
For the reality. So
I mean, that's been an issue with Android for a long time, the fragmentation of platforms.
correct.
And the older versions of Android be terrible, like performance is really bad,
Correct.
major security issues.
Even the browser engine itself.
Yeah, I know.
I mean, that one that I show you, I had to fix something for older browsers.
Yeah, if you're writing a plugin that you expect that to happen, I would just assume that it will.
Yeah. Well, no, I mean, because since the plugin of the camera is being supplied by Cordova / Adobe,
Yeah.
you know, that's where I'm going. But that's not the only animal.